Road cycling functional components. Most people know how to ride a bike, and there are many different kinds of bicycles and many different kinds of riders. Let's look at the functional components of a road cyclist, perhaps someone who bikes on the weekends, commutes to work, or even competes. The act of pedaling is broken down into phases, and each phase has different biomechanics. Think of a foot pedaling around a clock. The foot begins at the top or at 12 o'clock. In the beginning of the pedal cycle, the rider's pushing hip is flexed and the knee is flexed. Cycling shoes have stiff soles so that the downward forces generated from the leg to any part of the foot can be efficiently concentrated on the pedal. The gastrocnemius, soleus, and tibialis anterior stabilize and keep the foot in a neutral position. At this 12 o'clock point, the gluteus maximus and hamstring group concentrically contract in order to move the hip into a more extended position. This movement is performed in the same direction as gravity. The 3 o'clock position. As the foot comes down and around, the rider's hip and knee are beginning to straighten or extend. The quadriceps group is now engaged to concentrically contract and extend the knee. The ankle, plantar flexors, and dorsiflexors stabilize the foot and allow the force to be transmitted to the pedal. These movements are in the direction of gravity. At 6 o'clock, the hip and knee are at maximum extension in the pedaling cycle. Some riders will engage the plantar flexor muscles, the gastrocnemius and soleus, in a toe-lowering movement that helps to push the foot into upswing. The latter half of the movement, back to 12 o'clock, will return the knee and hip into flexion as the opposite leg is performing. This returning is performed eccentrically against gravity. The 9 o'clock position. Note that the cyclist is wearing special shoes that allow the pedal to adhere to his foot. The flexion part of the cycle is really a resting or recovery time. The other leg is performing the powerful movements of extending the hip and knee. The tibialis anterior, the foot dorsiflexor, brings the foot back from the plantar flexion position to allow stability and upward pull. Back to 12 o'clock. The hip is returned to its most flexed position. The knee is also at maximum flexion. The ankle is at slight dorsiflexion. The cycle is ready to become repeated. There is no force coupling required for these movements. Now we will address the upper body movements during a ride. Upper body functional movements. The trunk is in a flexed position, resting on the hands or elbows of the cyclist. The erectus spinae isometrically contract to maintain a flat back. The core, transverse abdominis, external and internal obliques stabilize the trunk. During the pedaling movements, the pelvis shifts from posterior to anterior, causing slight rotation in the spine. The trunk balances these movements with the recruitment of the erectus spinae, quadratus lumborum, and deep intertransversarii muscles posteriorly. Anteriorly, the external and internal obliques allow for the twisting of the trunk. Upper body continued. Neck extension is achieved through the isometric contraction of the splenius capitis, splenius cervicis, and upper traps. The hands grip the bars utilizing isometric contractions of the intrinsic hand muscles, along with stabilization of the wrist by the flexors, flexor carpi radialis, flexor carpi ulnaris, as well as the extensors, extensor carpi radialis longus, extensor carpi radialis brevis, and extensor carpi ulnaris. The triceps maintain an extended elbow isometrically, and the trapezius, pectoralis major, and latissimus dorsi help to stabilize the shoulder and trunk. Impairments of the cyclist. The example on the right is a professional rider. Observe the deep hip and trunk flexion, as well as the forward rounding of his shoulders. Notice the hyperextended position of his neck required to allow him to see the road ahead. Due to the lack of complete hip extension, The hip flexors, iliopsoas and rectus femoris, can become tightened. They would need stretching. Due to the lack of complete knee extension, the vastus medialis may be weak compared to the other quadriceps. They need VMO exercises like short arc quads, for example, or neuromuscular electric stim. Due to the prolonged flexion of the shoulders and position of the neck, the trapezius and deep cervical muscles may become tight and painful. They need postural correction, trigger point therapy, stretches, etc. Due to the flexed position of the trunk, the rectus abdominis may be weak. They need crunches, flutter kicks, and other rectus abdominal exercises. Exercises to enhance cycling. Endurance. Some people bike for hours, so any cardio exercise that would build up endurance would help that. Strengthening glutes, hamstrings, quadriceps, plantar flexors. You could do squats, leg presses, heel raises, etc. Strengthen core and erectus spinae, bridges, walkouts, Superman exercises, boat pose. Also strengthen triceps. You could do diamond press-ups, rope, triceps pushdowns. The end.